Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 76. In today's lesson, we're going to be working on our multiplayer game leaderboard. So I thought about what I wanted to do today. We have some to-dos, but I think I want to go ahead and start with the max heap. So last time we set up the basic structure and we added a dictionary. So the dictionary is the structure we're going to be using as a primary storage, but there's also going to be storage for other data types. So we're going to have an ability to find a specific player. Going to show the top players. That's what we're going to use the max heap for. Show rankings and so forth. So we'll just go ahead and begin with the max heap today. I feel like that was a good next step. So I thought about it. So one thing we could do here, we could use the built-in priority queue, and that would work. I think I want to do a max heap though, since we did min heap, and that way we can have them both implementations, and then who knows, we may swap it out in the future. But I think this is what we want to start with. So I'm just going to begin here. So if we remember from our heap before, we stored it as a list. We did it as an integer, however. So in this case, we're going to need it to be a heap of player. So we had a count. I think we will probably use it, but if we don't, we may remove it. But the primary focus was the insert, peak, and remove min method. So we're going to have a remove max. So public void insert player. So something like this. So we'll have add to the heap. Int. So current. So I believe that's what we did before. So we start at the end, so we can just use our count we just did. So they will at least use it internally. So while current is greater than 0, so int parent equals, I probably did a get parent method, didn't I? Let's add those. Let's do private static int get parent. So we give it an int and we say I minus 1 divided by 2, and that should get us our parents index. That should be that. Right. Oh, I'm out of the class. We should also have a private static int get left child int I. That's not the formula I'm going to use. We can use 2 times I plus 1. So that got us our left child, I believe, and then we can do private static int get right child. And it's plus 2. That should get us everything we need. I'm going to add us a helper to do a swap as well. I think we did it last time as well. So we'll have a swap int x int y. So we'll have heap at x, heap at y equals heap at y heap at x. I believe something like that. So now we can use that get parent here. So get parent current right. So we grab the parent. Now if heap at parent is, so here this will be one of the first points. So on the minimum heap here we would do less than or equal to. So on max heap I think it'll be this. We'll see if this works. And then we break. Then we swap parent with current. And then current equals parent. Something is not right here. What am I missing? Cannot be applied to player. Where was player? Yeah, we did it as a record. What we wanted to do is we're doing it by score, so I guess we could just do score probably. So we'll see if that works. So we'll go ahead and do our next method. So we'll do public int peak count equals 0. Throw new invalid operation. Invalid operation exception. Heap is empty or the first value. That should be a player. IntelliSense is not getting it today. Alright, so now we will need to remove max. So public int remove max. So it'll begin with the same if here. So we'll grab all this. So now we will say if we'll make this the count and semicolon. So there's a certain value. So int max equals heap at 0. Let's get the first value from the heap. It's not an int though, it's a player. And then this one will be player as well. Alright. So let's see, we want to get the end of the array, so I think we'll just do it like this. Int I want to say end equals count minus 1, and then we'll do heap at the first position gets the value at the end. And then we just remove the value. So heap at the remove at end. And that should remove us the value, so that now we have to adjust and reestablish the heap. So we will do int current equals, we'll start at the beginning, so while true. Let's see, we'll need the left index. Int left equals get left child. Current. Int right equals get right child current. Int largest equals current. Alright, so now we want to do I think we did it as just an, I think we did it as if here. I could do it, you could do it as a nested if or as a combination. I'm going to do it as a combination. So if count, now, and I'm already doing it wrong, that's going to be a min heap, I want it to be a max heap. If the left count's greater than, if left is greater than count, and heap at left is greater than heap at largest. Right, wait a minute. Largest equals left. The same problem before. I want to compare the score here. Right, wait a minute. Is this right? Wait a minute. This gets us indexes. Let's continue. Let's continue. Might be mixing this up actually. We'll debug it if it is. Heap at right dot score greater than heap at largest dot score, and largest equals right. Now if largest equals current, break, else swap current and largest, and then set the variable there, and then at the end we'll return we will return max. I think that'll get us our heap, so I believe that's all we need. I guess maybe let's do a toString here. Public override toString return. Let's see. We'll do string.join. Here we can make it an expression body member. Control dot. Use expression body. Okay, I think there's us our heap. So let's test it and let's make sure it actually does what we think. So here we'll just do a test here before we get into the code. So max heap equals new. Heap dot insert. We'll do 10. No, that's the B player. New player. New player. Let's see, 1 name 1. We'll just do everything 1. Alright, so there's this 1. Let's print the heap. Oh, the method group there. Alright, let's do it again. And we're going to hit the insert key and we'll just do it like this. I'm just going to do it one more set. Bunch of 5s, 6s, 7s, and 8s, and do that one 8, and do that one 8. All right, so let's just see what happens here. We'll put a breakpoint here and let's run it. All right, so if we got their max heap right, this will look like we expect. So as a single player, then it has 2 players. 2's the largest. 3, okay. 4 is okay. 5, 6, 7, and 8. I believe it's working. So yeah, so I believe I got those flipped right. And we'll just continue, and we will exit. Okay, so I believe there's us there heap. So the leaderboard manager will actually do the heap. So in here, so we will have a private, read-only, max heap. Probably that, but we can supply it. All right. So when we add a player, we'll try add. Here, if we throw, we're done, but otherwise we will do max heap dot insert player. Okay, and there we've added it to the list. So here we will need to remove it from multiple places. So we'll need to adjust. So if, no, let's not do that. Let's do bool result equals players dot remove player ID. All right. So if result is true, then we will do max heap dot. That's a little trickier actually. Yeah, interesting. I hadn't thought of that. So what we'll have to do here is we'll have to keep the heap up to date. So let's do this. We'll have to do this another way. So there's remove max. Let's have a public void. Here we'll do bool remove player int player ID. Right, is that what we have here? Yeah, player ID. Dot remove player at player ID. So that's a little trickier. And then here we'll just return result. There. That looks a little funny. Let's add our braces here. All right, so this one's a little trickier because we're going to remove a player. So that's not how a heap's supposed to work, but I think we can make it happen. Right. Yeah, let's see. So I think we'll just end up basically doing the same thing as remove max, but we'll treat that one position instead. So let's try this. So we have this position. So we will start with this. So else, let's do this. Let's do we'll need to find it. So it's not sorted or anything. So I guess we'll just have to search. So we'll do int player index equals find player ID private int find player, int player ID. So we'll just search through. So for each player be in heap if player, can't do it as a for each, need a for loop. Convert to for, that's fine. So for each player, if p dot ID equals player ID, return I. Else return -1. Okay, so that should find us the player. So if player index less than 0, return false. Okay. So remove player, so it returns false if there's no player ID is not found. I think that makes sense. So otherwise, we'll do this. So else we found it, so we have the player ID. So we will make the let's do this. Let's get end equals count -1. So heap at player index equals heap at end. Heap dot remove at end. Current equals 0. Nope. No. Current equals player index. So instead of starting at 0, we're starting at the player index. Now while true. And then we're basically doing all this again. At the end, we return true. I think that'll actually do it. I wish I hadn't deleted my test code up here now. Max heap equals new. Heap.insert new 1 1 1. CW heap dot string. We'll only do a couple of them this time. Okay. So now let's do heap dot remove player 2. Oh, that was right. Heap dot to string. And now, if we put a breakpoint here, I think we get what we wanted. Nope, argument out of range. Why is it? Oh. Those should not have changed directions. So that should have been the other way on the top as well. It's less than the count. So that's not checking the value. That's guarding the making sure you don't go outside of the array. So let's try that again. There we go. So that was an easy debug session, and 2 was removed. Okay, I think that's a good sign. Let's make it a little bigger. I know I said I'd just do a few, but we're about to do more than a few. Insert 4 4 4 5 5 5 666. Alright, so we remove player 2. We remove player, we'll remove player 6. And then we will also remove max. Alright, now let's see what these do. Alright, didn't crash. So here we added 6, then we removed player 2. Player 2 was removed. Then we removed player 6. Player 6 was removed, and then we removed player 4. Or not 4, max, and it was removed. We should remove player 3 at the end as well, just to make sure the ending case works. So this is breaking the heap process by not doing the deletion how it should. But it's making it work for our purposes here. Alright, didn't crash, and it successfully removed the last value. So yeah, I believe that's working for us. So we'll go ahead and stop that. I'm going to comment this out just in case I want to do more heap testing here in just a second. That's a possibility. But I think that hooks us up a delete here. Now there's a lot of duplication here. Let's do this. Let's come up here and handle remove. Let's make sure we got that completed. So remove player, passing in the ID. Yeah, I think that works. So I think we're good there. We haven't implemented finder update yet. So now we've got two methods, or two data structures we're having the heap in sync. So let's do this. Let's go ahead and do show top players. We'll pass that down. Private static void handle show top players, passing in a leaderboard manager. That clears that one. Good. All right. So first things first, we will do top players. All right. So let's do this. Let's do how many players to display. So we will grab that first. So string yeah, let's do it like this. We will grab user input equals console.readLine or null empty. Now we will do int number of players to, display count. Display count equals user or int.parse user input to do make input handling more robust. Okay, so now we're going to grab the top that many players. So let's do it like this. Let's do leaderboard manager dot How do we want to do this? That becomes a little tricky because what I'm thinking is I don't want to remove those players, I just want the display. So it's like peak, but it's like peak the top positions. That's like you're pulling them off the heap, but you don't want it to be removed. So maybe we need to make a copy of the heap. Yeah, maybe that's what we want to do here. Which is not the greatest, but we can probably make it work. Yeah, let's try that. So let's do leaderboard dot get top players, and that will be display count. Let's create this method. So if we come down here, we've just created this, so it'll be public. And it'll return a list of player. All right. So this one's going to take a little bit more work. So list of player, top players equals this. And at the end, we're going to return that. But first, we want to do this. We will do top players equals max heap dot get top players, and we'll pass in the count. Let's rename this Control RR, number of players to display, and get top. So we don't have this one, so we'll need to add this method. So we passed it on down. It's down here at the bottom. Let's move it up just a little bit to here. We'll move find player here. So for first implementation pass, I'm going to implement this the easy way, and we may come back and clean this up afterwards. Yeah, let's do that. So we have the regular heap constructor here. We also will, let's do this. So we'll have public max heap public max heap, passing in a max heap to copy. So this one will do this. So it will take, there should be an easier way to do this actually. Wait a minute. I'm wanting to just do like have some kind of heap representation for this list, and it's just accessible. Okay, well, let's do it like this. Let's add another method, public list players, this player, let's do read only list. Is that not the right type? Read only list player get player list return heap dot as read only. All right, something like that. Let's see if this doesn't work. So now we will just do that. So we will do var players to copy equals heap to copy dot get player list. And now I guess the easiest thing to do here is just to play it. Now we don't need to do it, it's already coming from a heap. Yeah, let's make this internal. So it's already a list, so we can just do this. So we can just take the heap and do it like that. And we can do the new syntax there. And I think that should be good. So what we could do here, we could say heap equals this, move that, and there. I believe that'll get us a copy of the heap, so we can do it the easy way. So we can just come down here and we can say max heap copy equals new max heap, passing in this. So this points to your current instance, and I can just do this. So it points to your current, the one I am, and it says, okay, I'm making a copy of this. Now we will do for int I equals 0, I less than number of players to display, I plus plus, and now we will have a list of player. That, but we can simplify this. And now we will just do top players dot add heap at I. And it's not heap at I. No, that's definitely wrong. No, all right, wait a minute. It'll be copy dot remove max. There we go. And we want to call it however many number of player times. And then at the end we return top players. So however, there's a subtle problem here. So what if the number of the display, there's fewer ones in the list, so we need to account for that. So I'm going to assume that it's intended and you just return however many players there are if there's fewer than your count. So we will do var counter equals number of players to display if counter is greater than or equal to the count, then counter equals count. And I don't guess if it's equal to, we don't care. And then count gets used here, right? Should be int counter. Right, so now we grab the number of players and we say, okay, if the number of players is greater than the max count, then we just take the entire count. So say we've put 4 players in it and we ask for 5. I almost think I'm off by 1 here. Wait a minute. Let's test this. So glad we kept this around. Control U. Yeah, we will remove all the deletes here. So we have 6. So let's do this. So we will do CW string.join, comma, we will do heap dot what did we just call that method? Get top players. We'll say let's get the top 5 players and let's see who they are. Make sure our heap works. So the top 5 players are player 6, player 5, player 4, player 3, and player 2. That seems good. Now let's ask for the top 7 players. Didn't crash, so then we get 6, 5, 4, 3, 2, 1. Okay, that seems good. So now let's ask for 5,000 players. Didn't crash, and we get 6, 5, 4, 3, 2, 1. Okay, I believe that did what we wanted it. So if we come down here, F12. So now what this method's doing, it's making a copy. So to do, we could be more efficient to not copy this. So we'll think about that one as a separate to do. I think this effectively works though. So that gets us our top method. So get top players. I don't think there's any need to do this here. It's just going to pass that over. Right. Yeah, I think that'll work for now. Then up here, so handle this, so top players, so we get the top players, so our top players equals this. Now let's do this. Let's do let's do a do while. Do so here we will do CW, let's do 1 dot top player at 1 minus 1. Something like that. And then while we'll do this count int count equals 0 while count is less than top players dot count plus. So here we will do this. So we will embed count here. Count plus 1. So we want it in normal human numbers. Here we will just do this one's count. I think I need to add my braces, but I think that gets us our list here. So let's do this. Let's add a to-do here. To-do, justify larger counts. So we will want to do some padding there to make the counts line up. But let's see what this looks like. Here, let's skip the breakpoint. So we'll add a player. 1, 1, 1, 2, 2, 2. Oops. That was a mistake. Try that again. So add a player 1, 1, 1. Add a player 2, 2, 2. Add a player 3, 3, 3. Add a player 4, 4, 4. Add a player 5, 5, 5. Add a player 6, 6, 6. Alright, let's show the top. How many players to display? We will display the top 3 players. Okay. Yeah, we may clean up how those display in the future, but I think that looks alright. What I want to do, I want to put this on the same line and add a space here, though. So let's do that. So instead of console right line, we will make this be a right. And then let's do this. Let's add a CW. There. I think that will handle it for now. So that will get us our players. So let's do one more thing. I actually like the space there, actually. And let's do one more thing. Let's add a to-do. To-do. Let's not do it there. Let's do it here. Consider how we want to display the player stringification. Okay. So that gets us roughly one more feature in the show top players, and it also hooks up the max heap. So I think that's a good continuing point from last time. So the next ones are find player and update score. So find player is going to be interesting because my intention was to use a tree, so it'll be adding another data structure. For update score, it becomes a feature in all 3 spots. Like it'll be part of each of the features, so I think it'll be last. So I think we may look at adding a tree next time. So that is pretty much all we're got time for now. So let's comment this out so I don't forget it next time. So another thing we can start looking into is I've been testing it up there like that. What we could do is put some actually move these out to their own classes and start putting the some unit tests in. That could also be a thing. But yeah, I think I'm pretty happy with that amount of progress for one video. So we're starting to get a lot of to-dos, but some of these aren't going to be that hard. Let's put a to-do here. And by the way, the reason I use to-dos, they show up in Visual Studio. Tools. I think there's a to-do explorer in here somewhere. Task list. Yeah, there we go. So the task list here shows to do, and that's one of the ones it considers. I think there's other ones too. Let's see. Let me just Google that one real quick. Visual Studio task list. So the task list, to do, hack, or custom tokens. Several predefined are available for C, C++, and C Sharp and Visual Basic. Hack, to do, undone, and resolve merge conflict. Move to header is one for C Sharp. So the only one I've ever used is to do. So apparently hack's one of them. Look there. Yeah, hack 3. So what you can use them though here is to go to specific points of code. Let's see, how do I do this? So let's move this up one. So if we look at that, yeah, it still shows it there. It looks like from their example, there's a way to make it show the actual code where it's at. Yeah, I'm not sure. I'll have to play around with that. I actually haven't used this a ton. But basically, though, using to-dos like this, that's what it lets you do, is you have a list of them, so you can come back and keep track of which ones you've done, which one, and remove them, or see what you need to do and remove them. And that's why I'm putting to-dos on these, so we not only can we remember, but we have an easy way to find it. And you can find it with a search as well, but it's easier just to use the task list. And I use Writer more commonly personally, so it has a slightly different way of doing it. So that's why I haven't actually used a task list in Visual Studio, but I was pretty confident it had one. But yeah, so we'll call it with that. So this has been continuing our program update here, and I feel like we made good progress. So next time we will look into either some cleanup or this red black tree. That reminds me, there is one more thing. Let's add a to-do here. To-do. See if we can't combine remove logic. So what I think is that since this is just the same thing, just this is a 0 based, this is an index based, I think we can just abstract all this out into the private method and just use it for both of them. Doesn't necessarily give us a lot of benefit, but it can save us a little bit of code. So we'll think about that. Think about doing some cleanup or adding more. So we'll call it there. So thanks for watching and have a wonderful rest of your day.